start on this one in the morning.
What am I supposed to do with this? This doesn't tell me squat.
What's the problem?
Well, look at this repair order. I need more information than this. I mean, besides, the last time I saw one of these, I was in diapers.
Well, why don't you just refresh your failing infantile memory over in the service library?
Oh, very funny. Well, I'm glad that we got it, though. Hey, Ron, since you're 9 years older than dirt yourself, maybe you could explain a few things to me.
Well, if I can remember, what did you have in mind?
Tell me what you know about hydraulic brakes on Harleys.
Have you got a month?
Come on.
Okay. Look, it's quitting time. Why don't we get cleaned up and come back here in just a couple of minutes?
All right.
Harley Davidson Motor Company proudly presents this PhD Service Training Program. This program is designed to help you provide better service to your customers while you increase your service proficiency, professionalism, and profitability.
Well, buddy boy, are you about ready?
Where do we start?
Well, let's see. I thought maybe we'd start just by thinking about everything a brake's got to go through. High-speed braking. Slowing down.
How about stopping?
Yeah, and extreme temperatures.
Freezing conditions and de-icing salt, if you live in the snow belt.
Right. High humidity and water, road dirt, dust and sand. The motorcycle's brakes are subjected to a lot of harsh conditions. Lots of times the brake system is taken for granted. Some folks think that if the brakes stop the motorcycle, everything must be all right, but it ain't necessarily so. The hydraulic brake system has to be maintained to ensure the well-being of the rider, passengers, and others on the road.
You're right. I never really thought about it. Hey, Ron, I know the master cylinder is the heart of the system. Can you explain how it works?
Sure, piece of cake. When you use the brake pedal or the hand lever, a piston moves, increasing hydraulic pressure inside the master cylinder. Here, let me borrow that pencil. The hydraulic pressure then moves through the brake lines and hoses to the caliper, which pushes on the brake pads, which rubs on the rotor, slowing the motorcycle down. Now, over the years, Harley has used both cast iron and aluminum master cylinders, and hey, today is your lucky day. I took a scrap master cylinder and made a cutaway for the rider maintenance seminar that I put on last spring. Here, check out this beauty.
Hey, this is really neat. This shows everything.
Now, inside, there's a return spring, a rubber cup, a piston, an O-ring, and a snap ring. And you see these two little holes? They've got a major job to do.
I'm with you so far.
Now, this next stuff might be a little bit tricky, so try to picture this. This whole chamber is completely filled with brake fluid. Now, to keep it simple, let's say that there are two chambers, A and B. When you're not stepping on the brake pedal, nothing's happening, so there's no pressure in either chamber. But when you step on the brake, all sorts of things happen.
What things?
Well, when you apply the brake, the piston begins to move. Chamber A becomes pressurized just as soon as the edge of the rubber cup goes past this tiny relief port here. Now, the fluid in chamber A is pushing the lip of the cup against the wall, and the brake fluid has no place to go, so pressure builds in chamber A. As you continue pushing the brake pedal, the fluid is forced through the brake lines and end up pushing the piston and the caliper, which pushes the brake pads, which stops the bike. Comprendo?
Well, I'm with you so far, but what's going on in chamber B?
Well, that's a good question. At this point, not a whole lot. But when you release the brake pedal, a couple of things happen. The spring pushes the piston back, and the pressure on the edge of the cup is gone when it passes the relief port. Also, as the piston is returning, a small amount of brake fluid from chamber B flows over the edge of the piston and cup into chamber A. This fluid compensates for brake pad wear, and the passageway leading from chamber B ends up in the reservoir, and gravity simply pushes the fluid into chamber B, making sure that it's full all the time.
Oh, I get it. Now I understand why the brake pedal has to be adjusted properly on bikes that need it. If it's wrong, the relief port will be covered and the system will be pressurized, which means the brakes could start to drag.
Dave, you're a genius. Now, to see if the relief port is uncovered, all you have to do is apply the brake and watch for a little squirt. Looky here. See that? If you do see that, you know that the hole is being properly uncovered. Unfortunately, can't really see the squirt in the master cylinder with a remote reservoir. Hey, here's a little trivia for you. You know what this little baby is right here?
This? Well, I've never seen one of these things before. What is it?
That, my friend, is a very special part. It's a check valve. It's used in total drum brake systems. It keeps the slightest amount of pressure in the brake lines to prevent air from entering. Then provides instant brake shoe movement when they're applied.
What about sidecars? They've got drum brakes.
I said total drum brake systems. It's not needed with a sidecar if it's hooked to a bike using disc brakes.
Got it. Hey, Ron, what about rebuilding master cylinders?
First of all, never, and I mean never, ever hone any cast iron or aluminum master cylinders that came on a Harley. You got that?
Yeah, I guess so. But why not?
Hey, it's not worth the risk. How do you know that the bore is straight? How do you know that you're leaving the proper surface finish? How do you know that the bore isn't too big? How do you...
Okay, I won't. Well, I never thought of those things. You're right. But how do you know if a master cylinder can be rebuilt?
Oh, it's pretty straightforward, really. Here, take a look inside this one. Tell me what you see.
Well, I see some light surface rust, some rust pits. Well, I can't really tell how deep they are, and some scratches in the bore.
Good. Good description. Can it be saved? Would you install a rebuild kit or replace it?
Well, I'd replace it.
So would I, and I did just that, and the customer is happy. Now, don't get me wrong. Master cylinders can be rebuilt. If there's a minor leak, sometimes a rebuild kit is all it needs. But if I'm in doubt, I replace it. I'd rather be safe than sorry.
Okay, what about aluminum master cylinders and wheel cylinders?
Well, the same holds true for those too.
Got it. Okay, now that I understand the master cylinder, how about laying some caliper theory on me?
I don't know, that's some pretty intense stuff, but if you think you can handle it...
Hey, I can handle it. Well, I don't suppose you happen to have another one of your custom cutaways.
Ta-da! Actually, this is pretty simple stuff. Basically, you have a smooth-walled piston, a caliper bore with a groove cut in it for a rubber square ring, and a special undercut in that groove which determines the retraction of the piston.
Whoa, run that by me again, will you? This time a little slower.
Okay, Dave. Is this better?
Very funny. So you're a comedian, too.
Seriously, let me show you how this caliper works. Now picture this. The piston to bore clearance is only a couple of thou. The square ring fits into the groove that's cut into the bore. And this square ring holds on tight, and I mean tight, against the outside diameter of the piston. The undercut, right here, determines how much the piston will retract. When you apply the brake fluid pushes out on the piston. Now remember, the square ring is holding on tight to the piston, so it starts to twist or deflect as far as the undercut. Then, when the brake pedal is released, the fluid pressure is removed and the square ring returns to its original shape, causing the piston to retract.
Okay, but how does the piston adjust itself to compensate for brake pads wearing?
Well, you've just answered your own question. The piston is self-adjusting. The brake fluid pressure can override the grip of the square ring and slide the piston outward until it meets the resistance of the brake pads against the rotor.
And I bet the same rules apply to rebuilding the caliper.
You bet.
Hey, what about all the different piston sizes I've seen on different models?
Now that's a tricky one. That's left up to the engineers at Harley. The way it was explained to me was that it has something to do with hydraulic ratios, you know, brake pedal and hand lever efforts, master cylinder bore sizes, and piston travel.
Well, they've been doing it right so far because the brake systems have been working just fine.
And that's a fact.
Thanks, Ron. I think I understand exactly how a caliper works now. Of course, I still got to fix this relic.
Yeah, she's a beauty. So what else do you need to know?
Okay, here's a tough one. Tell me the differences between .3 and .5 brake fluid.
Hey, I thought you said a tough one. Listen up. .3 is a glycol base, which means it will damage painted parts. .5 is a silicone base, which means it won't damage painted parts. .3 absorbs moisture, and brake systems that use it should be flushed once a year. .5 doesn't absorb moisture and doesn't require flushing. .5 also has a much higher boiling point than .3, which means that it's harder to turn the fluid into a vapor, which is compressible, and it'll give you the spongy pedal. And don't mix the two types of brake fluid together. You're only looking for trouble. By the way, Harley started using .5 in September of 1976, so be sure to use only .5 in anything from then on. There, you got it?
Hey, how'd you know all that?
I read the back of the can and the service bulletins in our library.
I should have known. Hey, Ron, what about rubber parts? You know, the cup and the O-rings that go with these two brake fluids.
Well, just remember to only use genuine Harley Davidson parts.
Well, if other brands fit, what's the big deal in using them?
Dave, you poor misguided soul. We only stock Harley parts, and with good reason. You know exactly what you're getting. You know that they'll fit, and that they're compatible with both types of brake fluid. And the other brands? Well, if an off-brand piston cup or O-ring were to react with the brake fluid and swell up and stick in the bore, or cover the relief port, you know what could happen.
I don't know what got into me. You're absolutely right. It's not worth the risk. Brakes are too important. Say, what if the owner of this bike wanted to convert it from a .3 to a .5 brake system? What do you have to do?
You tell me.
Okay. I disassemble and flush the entire brake system using .5 brake fluid. I'd change the O-ring and rubber cup in the master cylinder, change the rubber parts in the caliper, then inspect the cylinder bores looking for damage, making darn sure they're in good shape. How's that?
Not bad, but the list isn't complete yet.
What? What'd I miss?
Brake hoses.
Brake hoses. What for?
Well, let's think about what they're exposed to and what they got to do. They transfer brake fluid throughout the system. They're subjected to extreme hydraulic pressures, nasty weather conditions. They're always flexing and are continually attacked by ozone.
Well, now that you mention it, I have seen brake hoses that are hard as rock. Some that are weather checked and others that look just plain nasty.
So, add brake hoses to your list of things to do.
Boy, you're a slave driver.
You've got to be thorough when you're doing any kind of service work, but I'm especially careful when I'm working on brakes.
I'm just kidding. I know the importance of doing quality work.
Okay, now, what's next?
Well, let me think.
Well, I'd inspect the calipers and check the condition of the caliper pins.
Why?
Well, the pins allow the calipers to free float. You know, adjust themselves with pad wear. And I'd choose the right lube for the pins. Well, depending on what caliper I was working on.
Hey, where'd you get that tube of Molly 44 Light?
What, this stuff?
Yeah.
Ah, it's a secret.
Oh, come on. Where'd you find it? I've been looking all over for that stuff.
Right there in the service library under Tech Tips. Gave me the phone number and everything.
Jeez.
Always glad to help. Hey, where was I? Oh yeah, calipers. P&A also has pin rebuild, anti-rattle, and spring kits available for older calipers.
Right you are. What about brake discs? What makes a disc good or bad?
Well, let's see. The disc usually has a minimum thickness stamped on it near the fastener. Now, it should be mic'd up in 4 different spots, and it can only have a variation of 2 thou. Otherwise, you'll feel the pedal or hand lever pulse, and if there are any cracks on that disc, it should be replaced. Also, it's completely normal to have the surface groove, sort of like a phonograph record. Well, that's all I can think of.
What about disc run-out?
Oh, that's right.
All you have to do is put on your handy-dandy dial indicator, adjust it to 0, and give it a spin. The maximum allowable run-out is 0.08 of an inch.
And if it's more, you'd replace the disc, right?
Right.
Then after doing all the checks we've been talking about so far, I'd finish up the .3 to .5 conversion by bleeding the brakes. Hey, didn't you just get a new brake bleeding tool in?
Yeah, you mean this. Yeah, you gotta have the right tools to keep your efficiency rating up, and they almost always pay for themselves.
Which method do you prefer when you bleed brakes?
Well, I've used them all at one time or another. The pressure method, the vacuum method, the old reliable squeezing the lever method. They all get the job done. I guess it's personal preference.
Ron, how do you know all this stuff? What's your secret?
You learn a lot just by getting your hands dirty. And plus, I've been a professional tech for a lot of years. But just about all of this stuff that we've been talking about has been given to us by the service department in Milwaukee. Yeah, I always read the service bulletins. I watch the service update videos, the AV programs on microfiche, and I do all the PhD workbooks. Oh, and I can't forget Tech Tips. And if I just can't find what I'm looking for, I talk to the factory. We've got the information, so it's up to us to use it to our advantage.
How do you remember it all?
But you just can't remember it all. That's why I make checklists. It helps me keep all the information organized, and I just happen to have one on hydraulic brakes from the rider maintenance seminar that we did last spring. It's tools like this that make the job a lot easier. You can remove the guesswork. Here, may even help you out when you get started on that, Jim.
This sure is a complete list. Thanks. Thanks a lot. I'm going to use this. I'm also going to see about getting work orders that are more complete.
Whoa, look at the time. Hey, we better get out of here before the boss starts charging us rent.
Yeah. Hey, I really appreciate this.
No problem. Anytime.
Hey, listen, if you've got the time, I'm buying.
How can I refuse? Here, Ron. Let me grab my service manual.
Your service manual? What for?
Well, to maintain these. I just check out sections that I'm rusty on. You gotta stay on top of things.
Ron, you need serious professional help. Hey, you know, I've still got some questions that need some answering. What if the...
This PhD service training program was designed to help you provide better service to your customers while making your service operation more proficient, professional, and profitable. For additional training, attend the courses offered at the Harley Davidson Technical Training Center. Call the service department for more information. This program was produced by the Harley Davidson Service and Technical Communications Departments.